Welcome to an exciting lesson showing a useful trick. In this demonstration, you will learn how to use the NumPy library function linspace to plot evenly spaced numbers on a graph, and how to use the matplot function grid. The linspace function, shortened from linear spacing, divides a range into the given number of points and has three parameters: the starting value, the ending value, and the number of points to be plotted. For example, linspace 0, 5, 6 will plot 6 points, starting with 0 and ending with 5. This means if your interval is n, the number of points must be at least n plus 1, or you will need one more than the number of intervals you want because the initial and final points are included in the final argument, or the number of points. The linspace function is useful for plotting circles, regular polygons, and other functions and curves without distortion. We only need to use linspace on the array of x values. This x array will be passed into the function you want to plot. Adjusting the number of intervals changes the smoothness of the curve. Let's start by plotting the graph of the function y equals x times the quantity 4 minus x. As a second-degree function, or a function where x is squared, we should get the U-shaped graph of a parabola. After importing our NumPy and Matplotlib libraries on lines 1 and 2, we define our x array using the linspace function. Our y array is defined as a function of x. Then we see the familiar plot command with plt.plot. Next, we introduce a new command, grid. Grid is a versatile function that can be tailored to produce a variety of graph styles. In this case, we are using the default parameters, which draw both x and y axes and tick marks along major grid lines. Finally, we display the graph with the show command. Notice that the function plot is not very smooth. This is because we only specified 6 points for our x array. If we increase the number of points, the graph will be smoother. Let's try another function with a larger number of points. The graph of the function y equals 1 over the quantity 1 plus x squared has a mountain-like shape. We define the x array using the linspace function. This time, we set the interval from -2 to +2, which will center the graph on the y-axis. And we subdivide the intervals into 40 pieces using 41 points. Next, we define the y array as a function of x. X squared is written as x asterisk asterisk 2, as two asterisks next to each other tells Python to raise a number to a power. The Matplotlib function grid is called, and the axes are set to equal. Finally, we display the graph using the show function. This time, our function plot is much smoother. Smoothness is a trade-off with computational cost. It can take a long time to compute very smooth, complex curves. If you are interested in learning more about Python scientific libraries, check out the website scipy.org, or look up functions such as linspace or grid to see what you can create with them using optional parameters. We hope you are starting to see some of the benefits of using Python as a programming language. Try plotting a few functions out of your math books to see how they look. And I'll see you in the next video.